I'll just post a message in the Zulip that that the speaker writes for those who want to come and see it.
Thank you. That was really helpful. I hope that more people would come back to listen to this nice
I'm sorry for the technical
no worries.
problem.
That can happen. That can happen.
I'm Anh Tuấn Hoàng from Queen University Belfast. I will talk about our application of convolutional neural network in side channel analysis. I will emphasize to the effectiveness of structure in deep learning and the importance of plain text in attacking data by side channel analysis. So side channel analysis based attack such as differential power analysis and correlation power analysis are well-known methods to attack cryptographic devices. More recently, it has been shown that machine learning can be used to improve side channel analysis and can obtain the secret key even when the countermeasures are present. But improvements can be applied to increase the performance. We targeted the open ASCAD database. We developed new CNNP model with some improve from the current ones with a small convolutional size of 3 and 5. Using max pooling instead of average pooling. Our neural networks are deep but narrow. Our models consider plain text as an additional feature. We combine multiple models together. So this shows the difference between our and the reference, the VGG16 based CNN model. The main difference are size of convolutional kernel, the deep and wide, or the structure of the neural network, and the usage of plain text as an additional feature. This graph summarizes the results from the for the models on the ASCAD variable key dataset. The guessing entropy of our deep but narrow CNN model is shown by the red line here. You can see here. Above that, the green line, this line, is the result from the reference VGG16 based CNN model. And below the red line, all these lines are the results from our CNNP model, which means plain text included. We can see that with 40 traces, the deep but narrow CNN model, this red line at 40 traces, achieves key rank 8. Other CNNP model below achieve key ranks 2, 3, and 5, while the CNN model, the VGG16 model, achieve key rank of 20. To conclude, smaller convolutional kernel size generally perform better than large one. Deep but narrow neural networks generally perform better than shallow but wide ones. Providing plain text as an additional feature improves the performance of the attack model. Please see the detail of our research in our full video and paper. Thank you very much. And please give me your question.
Thank you. That was a nice talk. I have one quick question. Actually, as far as I have understood, you tried your method on ASCAD
yes.
database.
Yes.
But I'm not sure if you can generalize your observation made on this database on other databases. Have you tried to just use other databases to see if the same conclusion that you have made about the kernel size can be extended to other data sets?
Yeah, in fact, to my understand, there will be no single deep learning model or machine learning model for everything. So in fact, in our case, we emphasize to ASCII variable key data set. And I believe that if we apply this into other ASCII, other AES database, we will need to modify the hyperparameters of our CNNP model to
Of
have
course, I
yes.
completely agree with this.
But we are not yet applied to other data set.
But the conclusion about the comparison between the kernel sizes, for example, actually on the very last slide, you have this. You said that smaller kernel sizes can perform better when compared to larger ones. Do you think that the same holds for other databases? So this is the nature of the traces that we collect in general, or is that what you have observed only for this database?
Yeah, I think I think in this we combine both the small size together with max pooling and together with the deep of the neuron network, and so the good result come from that three things together, and then come from plain text. So I think it will work good in other data set also, but if you modify some parameter in that, thing may change. And but anyway, I think it will work with other, even for other data set, it will work for small convolutional kernel size.
Thank you. That was really helpful. Very fruitful discussion. Let me see if there is any question for you. Let me just check the so I cannot see any other questions. Okay. There's no other question. Ray or Esteban, if you don't have any other question, we can. Ray, do you have any question?
Actually, may I have one short question? Yeah.
Of course.
Yes. In my understanding, the signal trace is basically does not include the information about the plain text unless the any key information or key guess. So why your method improves the performance of the FCA using the plain text feature in the model?
Yes. I think if we look into the data that make effect to the traces, you can see that there are three kinds of data we include into this. The first one is the key, the second one is the mask, and a third one is the plain text. And so if you remove some and if you consider all of them parameter, unknown parameter, of course your model must work harder to find the good result. And so if you have available information like a plain text and you consider it as an additional feature, you can remove some unknown factor from your model, and your model will work fast, will work better, I think.
Okay, thanks. Okay, okay, it's time to close this session. Okay, thank you, An-chan.
Yeah, that was really a very nice talk. Thank you, Antoine.
And I'm sorry for the technical.
No worries, that can happen. that's really understandable. Okay, thank you so much. Thank you for just attending this long session. And I think that's it from our side.